Hey guys, welcome back. Today our learning target is I can define and classify different types of matter. So we're going to learn about how to define matter and then the different categories there are within matter. So at this point, if you're working with your notes, you're reading and filling in the graphic organizer. So go ahead and pause here and do that. If you've unpaused me, that means that you've done the reading and you're ready to go over your graphic organizer. So let's go ahead and do that now. So, matter is anything that has mass and occupies space. Anything that has mass and occupies space is matter. So, as long as I can find the mass and the volume of you, you are fine. So, technically, matter is anything that has density, right? So, how else can we classify matter? Well, there's pretty simple. We can classify matter in two simple ways: as pure substances and as mixtures. Pure substances have a definite composition, so we know how they are constructed. Usually made up of a ratio of 1 to 2 or 2 to 4 or 2 to 3 based on its composition. Mixtures are a variable of composition, meaning it's just a collection of substances together. So pure substance, we're going to focus on pure substance. Sorry, Pure substances can be defined as either elements, so anything you see on the periodic table is a pure substance, or compounds, which is a combination of elements, either into a 1 to 2 ratio, a 2 to 3 ratio, or a 2 to 4 ratio, or even a 1 to 1 ratio, right? So a compound, for example, would be H2O. It's a combination of hydrogen and oxygen. Another compound would be try to know nothing. Iron sulfide. It'll be a combination of iron and sulfur. Those are compounds because they end up combining together to form a new product. Elements, as I said before, are um, substances that we find on the periodic table as is. So we have iron, sulfur, hydrogen, oxygen, silver. Those are elements. They are always by themselves. Now, some elements might be diatomic, meaning they might come in pairs of two. So you'll never see hydrogen or oxygen or nitrogen in society or in chemistry or in science by themselves. They're either combined with another element or they come in pairs. So you always see like N2 or H2 or O2. That's because those elements cannot be by themselves. This is why we call them diatomic. Di being two, atomic mean atom, so two atoms, right? So those are our pure substances. Now we have our mixtures where we can physically separate them. Now we have two types of mixtures. We have homogeneous mixtures, which means uniform throughout. It's also called a solution. I like to think of homogeneous mixtures as mixtures that you look at that you can't differentiate from. So what I mean is I'm looking at water and I can't tell the different particles within it. It all looks uniform. It all looks the same. That is a homogeneous mixture. So by looking at it, you can't tell the other substances within it, meaning it's going to be very difficult to separate. However, we have heterogeneous mixtures, which are non-uniform. So you could tell the difference between the two substances. Usually this happens with soup, it happens with granite. If you see the little stones within it, you can basically separate it. If you have a mixture of like soil, salt, sand, you can separate those up into their each separate components. So heterogeneous mixtures, you can see the difference between the mixture. You can see each particle as is. In a homogeneous mixture, you can't see it. It's all uniformed, like air or tap water. All right, so these are the different classifications of matter, right? We have pure substances, we have mixtures. We can break pure substances up into compounds and elements. While we can't physically separate compounds, we can chemically separate them into elements. And then we have mixtures where we can physically separate with homogeneous and heterogeneous mixtures. All right, so here we go. So let me give you a couple examples because we will be working with um, particles. we will be working with particle diagrams, and its particle diagrams are very simple. They are basically circles that are drawn to represent elements and the different combinations of elements that we have. So you should be able to look at a particle diagram and say, okay, I know that this is an element, this is a compound, this is a mixture, right? And it's hard to use um, particle diagrams to differentiate homogeneous and heterogeneous mixtures. We just like to say mixtures as a whole. However, there is a way to differentiate with particle diagrams, and we'll see if I talk about that in today's video. So the first image we have right here, hydrogen atoms. Like I said, hydrogen atoms are diatomic atoms. Di meaning two, atomic meaning atoms. They cannot be found by themselves, so they will always come in pairs. Now, I know these are hydrogen atoms by themselves because I have one type of circle and they're all the same color. So one type of circle and it being that same color will represent one element. If I have a different circle that has a different color, that would be a different element. So each circle represents its own element. So the first one would be an element, hydrogen, right? Together. Next, in the next flask, we have oxygen atoms, which are the bigger circles that are a little bit red, and then they're also attached to hydrogen atoms, right? So these would be represent compounds, and they would be water. Now, number 3, obviously we could tell that we have two different types of elements here, right? We have the hydrogen and then we also have the oxygens, but they're not attached to each other, they're attached to themselves, but they're in the same realm of each other, right? So C would be a mixture of hydrogen and oxygen, and so would D be a mixture of hydrogen and oxygen as well. So we had this question for you, and this will not be on your notes, but it's good to practice, right? Which particle diagram represents a mixture? Now remember, each circle represents its own element. If I bring a different type of circle into it, it's now a different element. So if I look at these answers, which one can I eliminate because it's just an element? If you said 3 and 4, you are correct, right? 3 only has one type of circle, so that means there's only one type of element in that box. And 4, even though we have the same two elements, even though we have the two circles combined, they're still the same color, meaning they're the same element. So 4 is out. So we're left with 1 and 2. 1 and 2 being represents a mixture. Let's see. Our answer is, if you said 2, you would be correct. Now, 1 isn't a mixture because even though we have one element attached to another element, they are attached. So that means they are a compound. And because we see that compound all over the box, that means it's just one type. Okay, question number 2 says, which particle diagram represents a pure substance? Now remember, pure substances are a definite composition. So either we're going from a 1-to-1, a 1-to-2, or a 2-to-3 ratio. And it's either an element or a compound. Now, I want you to tell me what is wrong with this answer number 2. Right? Question number 2. I want you to tell me what's wrong with it. I want to hear from you during the live session what you think was wrong with this question. All right. So over here, I want us to go through a couple of them and see if we can define which one is an element, a compound, or a mixture. Let's see if we can do that here, right? And you know what? I'm going to play this little game with you guys during the live session. because I don't want to give the answers away. So I want you guys to join the live session, and we'll play this game together, and we'll see if you really understood how we classify matter. All right, guys, go ahead, complete your notes for today. If you have any questions, please feel free to ask me or Mr. Shores, and we will see you next time. Have a great day, guys.